Okay, so for 8-4 improper integrals, we're just going to go over a couple of examples. So here's a question from the end of the section. It says um, f is between 0 and g, and some a, uh, inclusive interval, including a to the right, where x is bigger than a. So if you know, beginning at a and going to infinity, that f converges, then g has to converge. True or false? Okay, and you can pause the video. You need to think about that. But the answer is false. I mean, because g is above f, it may converge, but you don't have evidence that it does. Okay, it's a converse error. You can't exchange with what's in front of the if with what's in front of the then. All right, so we're going to start with example 3, which is on page 460 of your book. And it's a good example because it gives you practice with fraction decomposition. And I'm not going to walk you through all the steps, and you can look at this in your own time. But here's the question, and you want to know what's going on with this. Does this converge or diverge starting at 0 to the right of this function? Okay. So what are we going to do? Well, we factor the denominator. Here's the fraction decomposition. Let me pick up here. So we can rewrite this the sum of the integral from 0 to infinity of this plus from 0 to infinity of -1 over x plus 3. And then I just break that down into the difference of these two. But then what you're doing is you're saying, I want the limit as b goes to infinity, and I replace this infinity symbol with a b on the left and right integral. So when you anti-differentiate this, you get the limit as b goes to infinity of the natural log of the denominator from 0 to b, subtract natural log of this denominator from 0 to b. You just do this each part. You put b in here for x, and then you put 0 in there. So you get the limit as b goes to infinity of the natural log of b plus 1, subtract the natural log of 0 plus 1. Subtract on this side the natural log of b plus 3, subtract the natural log of 3. So property of limits, you can rewrite this as the limit as b goes to infinity of ln, this ln1 is 0. And you bring the subtraction over here and put it in the denominator, b plus 1 or b plus 3, plus ln3, which is what? Well, that's going to give you the natural log of this, which this is another way of L'Hopital-ing it. What I did was I multiplied the numerator and denominator each by 1 over b and distributed that. So this would be 1 plus small over large divided by 1 plus small over large. And the natural log of 1 is 0 plus ln3 gives you ln3. Okay? So that's telling you that this thing has a value of ln3. Okay, so we're going to pause the video and go to problem number 13. So 13, here's the fraction decomposition. I want you to hear, when you look at this, it's essentially the same question with the different numbers, and it ends up giving you ln2. But this technique right in here on this last line is the same thing as L'Hopital-ing. If you L'Hopital this, you would get the derivative of this would be 1 plus 0 over 1 plus 0. The same thing. The natural log of 1 is 0. Okay? So for example 4, example 4 is a combination of improper integration and parts. So here's the question. So I rewrite this as the limit as b goes to infinity, and I replace this infinity with the b. Now I have x times e to the negative x, which you just do by parts. X is going to differentiate to 0. E to the negative x gives you this over here. This would be the positive product, negative product. This would be 0 times that. So we get this. X times e, x times the negative e to the negative x, plus a negative 1 times e to the negative x, from 1 to b. That is the value of the integral. So then what? We put a b in there for x, subtract, put a 1 in there, and we end up here. And I know I'm going fast at this, but you can slow this down and go over the PDF at your own pace. And we end up with this. Ready? This is e to the negative b, which I wrote as e to the b in the denominator. There's your numerator. I took a negative 1 out of the parentheses. And this is e to the negative 1. That's in the denominator. This is negative 1 plus a negative 1 is negative 2, but I'm subtracting that, so I just made this plus 2 over e. And then this time I did show L'Hopital, but you could have multiplied by 1 over b. And this thing is going to be its own derivative. Okay. And you get, this is going to small over large plus 2 over e, which is the value of the integral. Okay. So you're going to pause this and go to 17, and then the solution to 17 is on the bottom of the PDF. Which is the same question, except the exponent's negative 2x. So what do you have? I have e to the negative 2x, and you're anti-differentiating that. So this is e to the mu. So in order to get this, you want this to differentiate there. So the derivative of itself would be e to the negative 2x times a negative 2. So that negative 2 must have, you don't see it up here, so that must have had a negative 1/2 out front in order for that to give you the 1. And you just repeat that on those two steps. And you end up with the same type of thing. L'Hopital in this step, and you get this, the limit as b goes to infinity of small over large, plus this thing, which doesn't depend on b. So the value of the integral is 3 over 4e squared. Okay?